Now at this stage, we want to look at factorization by method of grouping. Now, factorization by method of grouping is self-explanatory. In this algebraic expression, we are going to group the terms in the algebraic expression according to their common factors. Don't forget that under common factors, we saw that there was a highest common factor in all the terms for the algebraic expression. But in this situation, if we check the question a squared minus am plus ab minus mb, you realize that the common factor a is in the first term, is in the second term, in the third term, but not in the third term. So we can't refer to it as a common factor. So what we have to do is we have to break this expression into two different terms where we are going to get a common factor for each of the group. So we are going to group them according to their common factor. If you check a squared minus am, there is a common factor called a. So the first group will be a squared minus am. So let's group it. A squared minus am. I put it in a bracket to show the group. When I'm done, then I'll factorize with the common factor. Now let's go to the next one. So I'll bring my positive sign plus. Let's see, the next group is AB minus MB. Why? Because there is a common factor B. Now, I have clearly grouped them into two because we have four terms. So the best I can do is to group them into two. Now let's go ahead and factorize by their common factor. Checking the first group, a squared minus am. A is a common factor. So we factorize a out. We open and close the bracket. As usual, a squared divided by a will remain with a. Let me demonstrate it here. A squared divided by a. A into itself is 1. A into a squared is a. So the answer is a. So we put a here. Good. Let's go to the next one. Minus am divided by a will give us minus m. So minus m. Now we go to the next step. We bring the positive sign. Now here we have b as a common factor. We bring the b, we open and close the bracket. Now ab divided by b will remain with a. Minus mb divided by b will remain with m. Now in this situation, we can see that in as much as we have factorized, there is still a common factor. A minus m in the bracket is common with a minus m. So we'll factorize a minus m out. That is to say, we will draw two different brackets, first and second. Now, those of them that are the same inside the bracket, we'll keep them in one bracket here. So we have a minus m. Checking from this side, a minus m are the same. So they get one bracket. Then the rest, the numbers in front of the bracket will now come. So I have a and I have plus b. So it becomes a plus b. So this is our final answer for the factorization, which happens to be a minus m into bracket and another bracket a plus b. Let's take a look at question number 2, which says factorize xb minus bz plus xz minus z squared. If you check again, from the first and second terms in the expression, we realize that the common factor is b. So we can factorize b out. Also with xz, the third term, and minus z squared, realize that z is the common factor. Now don't forget that in case the first two does not give you a common factor, you still have the go ahead to regroup everything in order to get your common factor. But in this case, I can get a common factor right from the first two terms. So let us factorize b out. So b out. We open the bracket, we close. Now that b is out, b will divide the b remaining with x. That means xb divided by b remains with x. So we write x. Then we have minus bz divided by b will give us minus z, which means b will cancel this b, remain with minus z. So minus z. Then we have the next two terms that we have z as a common factor. So the positive z out. Open and then you close the bracket. Now xz or xz divided by the common factor z. Z will cancel z, remaining with x. So we have x. Then we have minus z squared divided by z. Z will cancel one of the z from here, remaining with the negative z. So minus z. Now, if you check from the bracket, you realize that the first bracket and the second bracket are having the same numbers or the same terms. So we will factorize that one out, or we will draw two different brackets. Then the ones in the bracket will take one bracket, x minus z, since they are common. Then after you realize that, just pretend as if x minus z and x minus z are no longer there, they are here. What is remaining now? You realize that the terms remaining will be b and positive z. So it will be b plus z. Finally, this becomes our final answer, which is x minus z in the bracket and another bracket b plus z. Question number 3. It says factorize 3u squared plus 2ub minus 12uc minus 8bc. Checking from the first two terms of the algebraic expression, let's see whether we have a common factor. So when we consider 3u squared and then 2ub, we can talk about u as a common factor. So then we bring u out. Then we open and we close the bracket. Now that u is out, u will have to divide 3u squared. So if you check 3u squared, we'll use u to divide the u squared, remaining with just 3u. So it will be left with 3 and one of the u. Since u here will cancel one of the u, remaining with 1 and the 3. Then we go to the next one. Positive 2ub divided by the common factor u. We will see that common factor u will cancel this u, remaining with 2b. So we have positive 2b. To the next one, we have minus 12 minus 8. We can get a common factor minus 4. So minus 4 will be a common factor for minus 12 minus 8. Then checking the variables uc, bc, c can be a common factor. So at the end, minus 4c is a common factor. Open and then close the bracket. Now, minus 12 uc divided by minus 4c. Minus 4 into minus 12, it's positive 3. Then c will cancel c, remaining with u. Then you come to minus 8 divided by minus 4, we get positive 2. Then bc divided by c, we get b. So if you check, the one in the bracket here is 3u plus 2b. Also at this side we have 3u plus 2b. So we factorize the one in the bracket, then we will also write the remaining. This is what I mean. Draw two brackets. The one in the bracket, they are 2, so we give them one bracket. So 3u plus 2b in one bracket. Then the one outside is u here and the minus 4c. We have u minus 4c. At the end of the day, you get this as your final answer. So into bracket 3u plus 2b against another bracket u minus 4c is our final answer. Let's take a look at the fourth question, which says factorize 3p squared plus 2qt plus 6qp plus pt. If you check from the first two terms in this expression, we will realize that there is no common factor for 3p squared and 2qt. For that matter, we would have to regroup the whole terms in the expression to get common factors. Now, 3p squared will pair with 6qp as the first two terms. So I have 3p squared, maintain. Then we'll bring plus 6qp. So this will be our first group. Now we go on to 2qt, that is plus 2qt. Since it has a positive sign, it will be plus 2qt. Then plus pt, which also has a common factor. Now let's group them according to their common factor. Here the common factor will be p. So p as the variable, and if you check 3 and 6, we have 3 also as a common factor. So 3p is a common factor. Now we open and we close the bracket. 3 will cancel the 3. Then p will cancel p squared p. So we have p here. So that means when 3p squared is divided by 3p, it will remain with p. Then we have 6qp divided by 3p. So if you check, 3 will divide 6 to give us positive 2. Then P will cancel P, remaining with Q. So in effect, 6QP divided by 3P will remain with 2Q. Let's go to the next one. We have positive. Then if you check, the common factor here is T, so T out. Now, 2QT divided by T is 2Q, so 2Q remaining. Then PT divided by T is P, so plus P. Now, if you check this particular expression, we can rewrite this well. Those in the bracket are the same. This is P plus 2Q, and this is 2Q plus P. In effect, it's the same. That gives us chance to change the order of arrangement. So let's rewrite it well. So 3P into bracket P plus 2Q plus T. We will change the order of arrangement, making it P plus 2Q, which is still the same. Then we realize that those in the bracket are the same, so we draw two different brackets. In effect, we keep those in the bracket in one bracket. That is to say, factorize it out. P plus 2Q in one bracket. And those outside the bracket, which is 3P plus T, also in one bracket. So becoming 3P plus T. And this becomes our final answer.